Hello, Noah. I have a quick question.
Yeah.
How do we access the recording?
So I sent out an email with a YouTube link to the recording from Tuesday, and I don't think Hernan is still here. He's not. He took off. So I'm at the mercy of Hernan to send me the other recording links. Once I receive those links, I will be able to share the other recordings with everyone. I'll do that via email. If somehow I missed your email for the first recording, which was the second day, Tuesday, let me know, and I can make sure that you have access to that.
Well, for that one, I'm good. I just want the recording because I'm not going to be able to stay in throughout the workshop today. So I just want to, whatever I miss, catch it up later today and then before tomorrow.
Sounds good. Sounds like a good plan. I will email Hernan and try to get him to send me the link as soon as he can. And then as soon as I get it, I should quickly be able to get it to everyone else. If you would like, you can also email Hernan too, if you have Hernan's email. And there may be extra pressure on him to get it if he has me as well as other students in the workshop emailing him.
I actually don't have his email.
I can send it in the chat because it wouldn't be a bad thing as far as that to happen. So let's look up the state.
Well, thanks.
Yeah. So here's his name, and this should be his email right here. Copy email address, and let me see if I can send this in the chat then. Okay, there you go. So his email is in the chat. Okay, so yeah, you're welcome. So this is the handrail problem. And this is intended for you guys to try it on your own, using, at least for part of this problem, using a sweep command. You can hopefully see where you may be able to use the sweep command to make this part. So here's just a front view, top view of it, detailed view right here, and just an isometric view over here. So hopefully with all that, you guys are able to visualize how the part is in space, or what it would look like in real life. It looks something kind of like this. So we can try it as a group. Would you guys rather try to do it on your own or as a group? Yeah, you'll make a new one. There's no part provided. So in SolidWorks, which my SolidWorks is still starting up, amazingly.
Personally, I'd rather tackle it myself,
Yeah, no, I would encourage that. Does that sound good with you? Yeah. Lauren? Okay.
So what's on the handrail file? Here, just that drawing right there?
Yes, just this PDF, just the schematic. So based off the schematic, then you should be able to make this in SolidWorks as a SolidWorks part.
It doesn't look difficult.
It doesn't look that difficult, you're right. So go ahead and try that. And if anyone has any questions, let me know.
Oh, I have a question.
Sure.
I just got it off the email, and I forgot. I extracted it, and I forgot literally the next.
Well, the default is you extract it to your downloads folder. So then you can just navigate to your downloads folder via your file manager.
Okay, in SolidWorks, huh?
No, because it's just a PDF this time. So you can just open up your PDF using Adobe Acrobat Reader, and then you can look at that. And what I would say you could do, my SolidWorks still hasn't started, which is really frustrating.
That takes about 10-12 minutes.
Yeah, but it sounds like you have your SolidWorks open. So what I would say is you could split your screen so you have your instructions on the one side and SolidWorks on the other.
Yeah.
Or the other option that you can do if you'd rather use your full screen is you can just toggle between the two as needed. Work in SolidWorks, and then you think, okay, what's this dimension I need? You go over to your PDF and you figure out what dimension you need.
So it says extracted it and then handrail.
Yeah, handrail PDF.
and just open it?
Yeah, just open it. You can just double click it. It should launch it. Okay, my SolidWorks finally started.
Isn't that something that takes forever? It's terrible.
Yeah, and now even that it's open, it's still laggy, so I can't access it immediately. Let me see what the units are. Units are inches. It's doable. It is doable. Assuming all the tools work properly. How's everyone doing? Is anyone stuck or no? Not yet. You're good. I know.
Yeah,
Oh, I should have brought my laptop.
it's slower than it has been.
Oh, yeah.
SolidWorks is the reason that I felt the need to make my own computer, and I made it kind of overpowered for most things, but it's not overpowered for SolidWorks. Actually, there's a better way of doing this. So I'm going to undo that mistake. So honestly, the tricky part, oh, that's not what I wanted to do. The tricky part for this whole problem is getting the path of your sweep. That's, in my opinion, that's the main tricky part. Let me know if anyone gets it or if anyone has any questions. And be very careful too, looking at the dimensions on this on the schematic. Take advantage of those dimensions the best you can. Okay. Now, oh, I messed up. Made it worse. So I got my handrail created. How's everyone else doing? It's fine if you're not doing well. Phil, how are you doing?
I'm putting my sweep together. It's a little weird because it's hollow, right?
Yeah.
Yeah, it's a little weird.
Lauren, how are you doing?
I'm having trouble making the rail.
Do you want help or do you want to keep working on it?
Well, I did it once and it didn't look right, so I'm redoing it now. So maybe I do want some help. Found out where to connect them. I tried doing it at like the top right here, just the drawing line.
So when you look at the path, a good assumption to make is that what you're trying to draw is the center line, right? The path.
Yeah.
So a good assumption to make is that it's a smooth path. And mathematically, that would mean that you have like an arc or part of a circle right there, right? So a good assumption is that when you have the straight line, you're going from a curved surface to, or a curved line to a straight line. So if you want that to be like smooth in math, that'd be called tangent, right? Straight segment is tangent to the arc or the circle. So you can make a relationship between the linear line and both your circles to make a tangent. So
Will I just like draw a line and then make it hidden? Okay.
try that. Let me know if it doesn't work out. And how's everyone on Zoom doing? I think there's still only one of you. How are you doing on Zoom? Are you able to get the handrail or working on the handrail? Can you hear me on Zoom? Okay, well, hopefully I'll send a chat. No.
Very cool. I got everything, but it's not all of it. The second part. I'm making that one now. I gotta make it hollow, which I guess is second sweep.
You can do a sweep. You can also modify your cross section, right? How did you do your sweep? It looks like you did a circular cross section.
Yeah.
So you can use the feature.
Okay. Let me extrude this.
Sure.
How would I make that a thin feature?
If you go to edit your sweep, thin features and options, this little box that you check.
Okay. Guide curves, options, is that under options?
Let me check. No, it's below options. The next box should be thin feature. Do you see it?
The guide curves, options, start and end,
You're not doing a loft, are you?
sweep.
Yeah.
Edit feature.
I take it back because I'm sorry, I thought that you did a single sketch for your path and then you did the circular cross section default. But since you used two sketches, one of the first sketch right here for your cross section, just change this.
To a hollow.
Well, to it like a ring, right?
Okay, all right.
Yeah, you can get it with that.
Well, I changed the sketch and I added that circle, but it still didn't. How do I subtract it?
Select the area that you want. Oh, wait.
Oh, back to the sweep.
Yeah.
Sweep, edit feature.
Oh, no, you're good. Let me prove to you that you're good. So, do you know how to do a section view? Yeah. And then to toggle it off.
Thanks.
Yeah, no problem. You sneeze? Sorry if I'm mispronouncing that again. Are you there on Zoom? I think you told me that you were going to be missing part of today, which is totally fine. Lauren, how are you doing? Did that tangent thing work for you?
It did, yeah. My line is not in the middle. Did not think about that. Figuring that out right now.
So to add to the confusion, once you guys get your model or your part all made, if you look under the notes section in the prompt, it's asking you to change the material of the handrail. For the tube part, it's asking for 304 stainless, which my SolidWorks anyways has as an option. However, for the supports, it's asking for cobblestone 3, and I wasn't able to find that, so I just used balsa wood. But I can keep looking for the cobblestone. And I could probably download it offline. But let me know if anyone gets to that point, and I can help you out with that. Let me see if I have cobblestone here. Where is it? Yeah, I don't think I have cobblestone. That's okay. I'm not gonna worry about that. So Phil, did you get yours all done then?
I mean, I got the geometry wrong a little bit. I gotta, because I put the corner at 24 plus 3, but that's not, it didn't work. So anyway, the block, you know what I mean? The geometry is slightly off. Intercept. You can see it here. It's supposed to be level. When I placed that corner and then, you know, I rounded it, I placed it 24 plus 3 inches, but it's not right, I think. 24 plus 3 is not right. Yeah, that one's right. It's the other one that I got. I think I messed up that. I was getting this one. Okay, it's not far off, but it's maybe an inch. I probably can fix it. This is a challenging one. This is a good one.
I think it is a good one. You have to be real careful with the dimensions that they give you.
Yeah.
And you have to know the right assumptions to make. That's also a part of it too, like with tangent lines and whatnot, with linear line segments connecting with arced line segments. Mine's slightly different than yours, even on the lower joint or bend.
I might
But
have gotten that wrong. Let's see, I can straighten that out. Let's see, 1 inch. It's 1 inch to the start of the curve.
that is if you look at that, that's locating the center of the curve.
I don't think so.
So here, Phil, if you look at the big screen,
Oh, maybe it is. Yeah.
so that you have the center mark right there, the crosshairs, it's the center mark for the curvature right there. I think it just so happens that that also kind of starts the curve on the outside here. Well, actually at both points.
Yeah, that's how it looks.
But you got to be kind of careful with how you do that. So yeah, this one looks really simple, and it's fairly simple, but you got to pay attention to the details and be really careful with that, which is true of a lot of things. This not being an exception.
Let's see. Yeah.
How are you doing, Lauren?
I put the line in the wrong spot. I'm trying to figure it out.
You want help or?
Yeah, I think so. It's not in the middle of the. I did it once and then I don't know, I lost it.
Oh, you're trying, yeah, you want that in the center there. So
Yeah,
you have
yeah,
a few
yeah.
options. Go ahead, exit your sketch. I think I have an idea what you would have done. Can you zoom out? Okay, so hover over your two extrudes. Go ahead, click. Actually, I'm sorry. Go hover over your planes. I'm guessing you did those like in the front. Just Oh, the top one. Okay, that's fine. Mind if I use your mouse for a second? Okay, so you have a pretty easy solution actually. One at a time. Because I'm a separate extrude, which is fine. You can change this. This is going from your sketch straight up. There's an option to do it from the midplane, so it goes both directions equally. And if you don't want to, yeah, if you don't want to do that, you can actually specify which direction you're going in two directions. So you can do like 1 and 3 or vice versa, or you can do 2 and 2 here as well. But midplane is usually kind of nice for symmetrical things. And in the case that you have right here, it's not necessarily symmetrical, but you'll see, you may be able to figure out why this will help you. Because assuming that you drew, I'm pretty sure you did, I don't know how else you could do it, sketch 3 there, now it's centered. Yeah. Another way that you could do this too, I mean, this is, I wouldn't suggest this, but just so you know another way. I think that you would have no problem with doing that. If you remember before, we made planes with reference geometry.
Yeah.
So one thing you could do too is you could, if you pick for your first reference like this surface, for your second it's that surface, you'll get like a plane bisecting those two right in the middle. And then what you could do, you're gonna have to reorder that.
Did you put like the sketch on that?
Exactly, right
Okay.
here, edit sketch plane, and you can do that. Yeah, so this is another option. So, yeah, you just know that you have lots of ways. You can use that. You can go back and do it yourself. Do the other method or whatever you like. Anyone on Zoom, or is everyone away from the keyboard but me on Zoom? Okay. Nobody on Zoom, it seems, but me, which is fine.
I think the right side is actually right. The left side is wrong. You were right. I figured, I'll show you real quick. Yeah, I figured this side, I got the geometry wrong. I think it's what you said. And I think if I do that, okay, here's the original that I did, which is wrong. Here's a 1-inch line. I just threw it in there just now. Just 1-inch line. So I got to get that on top of that, or else redraw this one. So I'm going up 1 inch, right? And then you start the curve.
Well, yeah.
Is that?
Yeah, that does
Is that
happen to
wrong?
be the case. No, that does happen to be the case. So you could do it that way. I think what you can keep working on it if you want. Another thing that we can do is like walk you through my process. I think if you see my process, it will make a lot of sense.
Well, I'm like real close.
Yeah, no, yeah, you can do that. So what I would say, do you like to, how do you make that? Do you do it with like a fillet? Do you do it with an arc?
I did it with a fillet.
Yeah, with a fillet.
Yeah, I can do it with an arc. But I was thinking, actually, all I have to do is just redraw this line. And then this, tap, I guess it's called tap, the sweep. And redraw that, and then when I do this, modify the sweep, I put the sweep on this tap. You know what I'm saying?
Yeah. Go ahead and try that. Let me know.
All right.
You think it's simple, and it very well could be simple.
I'm not sure.
Let me know if you develop a question or run into issues. And anyone here in person or on Zoom, please feel free to ask me if you have a question. Phil, how's it going?
Yeah.
Okay. You still working on it, Warren?
I think I got it.
That's what you have.
I'm not sure if it's all right, but it looks like it was when I did this week.
Oh, you're not sure if it's hollow?
I'm not sure. It
So,
looked like it when I.
yeah. So here, yeah, it does look hollow, but the way that you can check for sure, select your front lane. No, which lane? I think it was the top lane. Julie. Yeah, click that. Sure. Yeah, that's fine. No, that's okay. The orientation doesn't really matter. Select right here, so we do a section view. And you should see that's my section. So what you can do, go ahead and orbit around, like rotate around your view, and drag that. I guess that you want that. Oh no, it's because sorry, I changed what you did. So you see that arrow right there? Click and drag that. Yeah, keep dragging it. But you can rotate it around, and then you should be able to see if that's hollow. Yeah, it's hollow. And then what you can do is you could press OK. And then just make that cool. And if he's doing that, you should be able to see the guys.
Oh,
So, and then if you want that to not be cut in half and not be looking at it like that, you can just click up there and turn off that section. Yeah. So that's the feature that you have. And then if you notice, like there was that orange arrow that you're dragging, and there's also two orange arcs that are perpendicular to each other. You can also rotate that. Exactly. Yeah. So actually, the next step is to change the material for that. So you can change pretty easily the material. Let me do it on the recording so that other people can see it. They would have seen me do it too, but I wasn't talking when I did it. So the easiest way, if you want to change the material for your entire type, for your entire part to be the same material, it's very easy to do. You can go and right click your solid body. Should be able to do that, and that mine's changed because I have 3 bodies now, or actually maybe right here. I think there's somewhere where I'll say like material, and then you can right click that or click that and go to edit material, and you get to select what you want to do. So you can change the whole thing to be some sort of metal. There's lots of metals in there, or all wood or something like that. The thing that I did, since the prompt is calling out specifically for 304 stainless for the handrail, that's the tube part that we made with the suite, and then the supports, which are like these rectangular prisms, to be cobblestone. I went and made my my extrude and my sweep separate bodies, which I can show you how to do that if yours aren't separate bodies. And then I was able to change the materials independently. So now this right here for me is the stainless steel. And then I don't have cobblestone on this SolidWorks installation, so I just changed the handrails to be wood.
it's 3 or 4 stainless steel.
Yeah. So you can like change the whole thing to be that. And then if you want the handrail or the supports to be a different material, you can make the extrudes independent of the sweep, and then you should be able to change the material for the supports. Now let me know if that's confusing.
I can't find the 304 stainless steel. Not the 304. just
Oh
the
yeah,
polished.
304 is stainless steel.
Okay.
So. And if you ever have a doubt, you should be able to search at the top there for a specific material. So you can just search for like stainless or specifically stainless 304 or 304 stainless. But the 304 should be the stainless steel that you're looking for. Did you get it, Phil?
No,
No. I think that may be a little bit challenging to do it that way.
yeah, I'll show you what I got. As I modified it, it became not defined anymore. And then sweep screwed up once it was not defined. So I'm gonna have to completely redraw the path.
You want to sit over here and watch me make it?
Sure. Yeah, but I'm gonna make it, but I'm gonna go ahead and try my way, but I don't have to do it now, you know what I'm saying?
Sure.
Because I know stuff can be done many different ways.
Yes. Yeah, no, that's
But I
true.
will watch. Give me 2 seconds. I'm just jotting down. The handrail is 304. I want to make sure I have the material. I'll just write this down and I'll take a look.
And then I would say the supports are, we'll say that it's balsa wood.
Also,
You laugh, but that's literally what I selected. I think it looks like decent wood. Mahogany looks pretty good too. I like oak, but the oak, I don't like the look of it.
How did you change just the like bottom parts? The part that's also wood right now?
Yeah, so for me, I extruded both these at once, so I have one extrude. Both of you have 2 extrudes. That's
Yeah,
fine.
oh, so you do it through that.
Yeah, so what
Okay.
you can do is you can do edit feature. And actually you would probably, sorry, you would do this for your sweep, assuming that you did your, which would you do first? Did you do your extrudes first or your sweep, or did you do like an extrude then a sweep and extrude? It depends on the
The
order.
extrudes first.
Okay, if that's the case, then you shouldn't need to mess with your extrudes. If you go to your sweep, however you have your sweep,
Yeah.
you want to deselect the box that says merge result. You typically always want, I shouldn't say always, I'll say you typically want to have that box checked. It's a good box to have checked. It basically means that like, if you have parts that are overlapping or just touching each other, it's going to fuse to that. And that's typically what you want. In this case, because they're different materials, I wanted that not to be
You don't
the
want to
case.
merge them
Exactly.
Okay.
because that way you can assign different materials to each one, you know, like the rail. and-
Exactly. So when you look up here now, when I did that, I didn't do that first, but once I did that, then I have 3 bodies up here, and then I'm able to select the material type for the bodies independent of each other.
This is a fun problem for sure.
It is a fun problem. I may steal it as a homework problem.
You want to show me the,
Oh, if you want. I
You
can
don't
do
have
it.
to.
I can no, I can do it pretty quickly. The other option that we have is just to move on to something else. But if you'd like to see it, I'm happy to show you.
either way, it's fine. I don't want to, you know, because it's getting a little late, so I don't want to screw up your.
Yeah. Well, we have like an hour left still. Lauren, would you want to see the way I made it? I mean, it's probably
Yeah.
sure you do. Okay.
Okay, there you
I'll do
go.
it then. So I'm just gonna, I'll say what I have. I think I already did save it, and then I'll just close that.
Hey, one question I have is
Sure.
where did you start it?
I'll show you. I'll pretty much
Okay.
redo exactly what
All
I
right.
did. And you'll see the method to my madness, maybe. There could be no method. Could just be chaos, but. So the way that I did it was I went to my front plane. And I always try to reference my origin. I'm actually going to draw, I usually don't do this, but I'm going to draw a construction line. I'm going to make sure that that's for geometry or for construction. I'm going to make this a midplane. And I like to make things with as few features as I can. That's the reason that I did the supports as a single extrude, and I'm doing this with lines centered right here. And I'm not really concerned about the dimensions just yet. And once I have that, I'm just going to set all these line segments to be equal with each other. Equal. And then that means I only need a single dimension right here. That's 4 is the right distance. And then the height right here, if you look at the PDF, is 12. Then over here, I believe it's 32. If I glance over, it's 34. It's wrong, 34. And at that point, I would think that that would be fully defined, but it's not telling me this. So what I'll do, oh, I see. I don't have the distance right here. So all I should need to do is set this distance right here, 52.5. And once I do that, now everything's fully defined. So if something's not fully defined, I just click and drag and see what moves around, see what degrees of freedom I have. And I'll extrude now. I'll do it not from the body. Midplane, there we go. And I'll go 4 because that's the proper distance. If you look at it, it's like a 4x4 square going up. And then since the reason I did a midplane extrusion is now I can reference the front plane and have my sketch be right in the center there. And the way I did this was I just drew line segments going straight up like this. And then next I drew in 2 circles. Hi, Peter. And then I drew just one more line right here. And then I just make relations between everything. So,
Tangent.
yes, tangent right there. Tangent right here. And actually I'm missing one. This should also be coincident right there to make sure that that's intersecting. Otherwise, when I go to the trim command, it'll give me issues. Make that tangent.
Interesting technique.
Thanks. Yeah, no, I tend to do things just in a way that I draw out all the elements that I know I'll need, and then I start constraining them. Usually first with relations, otherwise they tend to get in my way. And then once I have all my relations, before I start trimming stuff up, then I'll do dimensions. So I'm going to pick the, if you look at it very carefully, it's the center right there to this edge. I want this distance. Oh, by the way, my units are millimeters. So that will, no, 5.4. Oh, I guess not. Oh, shoot, everything's wrong. Okay, I'm going to do this in
Don't worry
millimeters.
about it. Just
I'm
go
going to
with
do
it.
everything in millimeters. And then
Yeah,
I'll-
yeah,
and
don't
then,
worry about
and
it.
then I could scale it, actually. I'll do that at the very end.
Yeah, don't worry about that.
Oh, I will, though, because I like to care. The details are important. So my radius is 1.5, so my diameter is 3. Hi, Peter.
I know, sorry, I accepted a little late.
That's okay. I'm happy that you're here. Okay, the diameter, I think that's the diameter. Yeah, it should be 6. And let's see, what else do we need? I think it's okay now if I, oh no, not yet. I need to set also that the distance from the center of this circle to the center of this circle. If you look, I'm actually using the dimensions straight from the schematic, from the PDF. Assuming that everything's fully defined in the prompt, which is, so now you can see everything's black, that means everything's fully defined except for like this endpoint's free to go in and out. But I don't care about that because I'm actually next going to trim that.
Trim it, yeah.
I'm going to trim that. Yeah, usually I personally never draw arcs. And I'll use fillets, but not usually like in here. I like circles.
Yeah, I
and
use
trim from there.
fillets. Probably circle's better idea.
Then I'll just go to sweep, and I want to do a circular profile with a thin feature. And my inner diameter, if you look carefully, this is giving the inner diameter. And I messed up on the math twice on this one I did first, but the inner diameter, because we have an 1/8 inch, it's 1/8 inch times 2 on both
1.75.
sides. Yeah, 1.75 exactly. And then for the thickness, in this case it's millimeters, but we'll fix that at the very end here. That would be 1/8 of a millimeter in this case. So when I need to pick the path. So there's my path right there. And so now this would be right, except it's not correct because
Don't
we're
worry
in
about it.
millimeters. I am going to care about it because it's very easy to fix. I'm just going to switch over to inches. And this isn't an ideal way of doing it, but I can just scale it. I can search for the scale command right here. And we're going to scale about the centroid uniform scaling 24.5 will give me exactly the inches. So once I do that, then it's all larger. And to confirm that that's the case, what I'll do is I'll evaluate and I'll just measure this edge right here. It should be not that, it should be 4 right there. So it's 4. So that's all good. And then, oh, one thing I forgot to do is uncheck my merge, which should be an option in here. Let's see here. Options, merge results. If I uncheck that, then I can set the materials if I'd like. Oh, my scale is no longer working. Oh, because I now have multiple bodies. So we'll select all of my bodies to scale. Okay, there we go. Oh, and it's all broken.
Don't worry.
Okay, well,
It got screwed up in the scale command somehow.
I should have done that very last. So yeah, if I don't do the scale command,
Yeah, I get the drift, and you nailed it. I mean, other than, but you did nail it. It's interesting, the geometry. You know, it's probably, you can do it probably 3, 4, 5, 10 ways, but the thing is, I think that probably with circles, it's more straightforward.
yeah, I like circles. Circles are a good thing. Yeah, and you're right. The geometry is really the important part.
The geometry is the part that snagged me.
Yeah, and so moral of this story is to be very careful with your units. Make sure that your units are right.
Oh, yeah.
That's something that will get a lot of people, including myself.
We've been having that as a long time, don't worry. It is, the geometry is interesting though.
Yeah.
Interesting how you worked it out.
Okay, so Peter, we were just doing the handrail sweep problem. This was actually the first problem we've done so far. We spent half the time today on that. So I think we'll move on to something new now. So I don't need to close that. That was just to give you guys an idea of how I did it. Ended up doing that, minus the fact that I used inches. But you can, if you do make a big thing in the wrong units, you can scale it at the end to correct that. Anyways, does anyone have any suggestions for what to do next? Here are our options. We can
Are
do
there other things kind of like that?
kind of like that. There's a very hard problem right here. It's a good problem. We can start working on it. And actually, I'd be very hesitant to just throw this one right at you guys.
Yeah, that one,
I don't know about
way out of my range.
We could try to do it all together and I could try to lead. This is one option, but then it's like, I'm just telling you exactly what to do and you're just, it's basically monkey see, monkey do. Me being the main monkey, but it's up to you guys. This is kind of, I think, let's see if there's any other problems. Usually that's the last hurrah if we get there. I've gotten there before and it's a fun problem, but it's very long. Lots of ways you can make mistakes with it. The other options that we have, so we've already done the lofts here, we've done the sweeps. So that's the other part that we would have. So we can go and do more advanced stuff with drawings, or we can do more advanced stuff with assemblies. My personal preference, I would opt for assemblies because assemblies are more important, more fundamental than drawings. That's just what my preference would be.
Yeah.
So you're good with that then?
Yeah, it's more fun to do.
Okay. Phil, you're good? I got a
Yeah.
thumbs up. How about everyone on Zoom? You guys can give me a thumbs up. You can unmute or whatever. If you're quiet, I'll just assume that we're good to go. Not quite. Okay, cool. Thanks, Peter. All right, so we'll move on. Actually, this is a fun thing. We can do the toolbox next. That's a fun thing to do. So let's do assemblies toolbox and mechanical. Ooh, and it's going to be an elliptical gear train, which I love elliptical gear trains. Planetary gear trains would be another name. So this will be good. This will be an assembly practice, and also we'll introduce the toolbox in SolidWorks. So in mechanical design, there's a lot of repeated features and fundamental elements. Now we have not elements like iron and hydrogen and whatnot. We have those, but when we talk about machine elements in engineering, we're talking about things like screws, gears, levers, slopes, which actually a screw is just a subset of a slope, but that's out of the scope of what we're doing for now. So I'll stop talking and we'll just get started on making an elliptical gear train. And we'll do this mostly from scratch, but I'll give you guys all the stuff that you need. So if you go to SolidWorks, you don't need anything open to begin with. If you go over right here to the design library, it looks like kind of like a bunch of books. And you go to the toolbox. This is a very useful feature. Since we have all these common elements that we have, like bolts, screws, washers, gears, a lot of standardized parts, we are able to kind of start with a template or a framework and work from there for making parts. So that's what basically this toolbox is. So if you go there, there's actually a high chance, I didn't have to, but there's a very high chance that you'll have to add in the toolbox. Usually every other time I've done this practically, I have to add in a toolbox. So it's just a thing that you click. It may take a while. It has to connect to a server online. And depending on your internet speed, it can take a long time. Also depending on what the internet speed of the server is. But anyways, okay, I'll ask and let you guys decide. Do you guys prefer US standard units or do you guys prefer metric units? Doesn't really matter, but I would prefer metric. But
I kind of already pressed the inch one.
okay, we'll go with inches.
Oh, I
then.
can
Doesn't
change it.
you can back out?
I
It doesn't
can
really-
change now.
All right, let's go to metric then, because metric is a good thing. And then if you go to power transmission, what we're going to be doing is making some gears. And if you can get to the gear section in here, let's see, we want spur gears. So if you click spur gear, you right click, you can say create part. And what should happen is just you're gonna get a part to pop up here, and it'll look something kind of like this, like a gear. And the nice thing about it is we get to configure over here a bunch of parameters. So the first thing I'm going to do, I'll leave the module alone. So I have 0.25, and everyone, I'm guessing everyone here is in the mechanical engineering department. In later courses, you'll talk in depth about what all these parameters are, but I think most people will be able to know what number of teeth are. At this point, I'm going to need a pen. Phil, do you have a pen by chance?
Yeah.
How about a highlighter? Just something I can draw with. A graphene, just a graphene pen or an ink pen. I guess it would be a graphene pencil. But let's see. We'll make the numbers nice, but we want to be a little bit bigger than 10. Let's do 30. And for the shaft diameter, you can pick, let's try 2. 2 looks like a good number. Thank you so much. And then it looks a little bit thick to me, so we can change that. We should be able to change that. We don't need a keyway, by the way. And for the, oh, here we go, face width. Let's try, so it's currently 12. So this is, by the way, a pretty small gear. That still looks large. So actually, you know what? Let's try to change this. Let's change this to. Okay, this looks good. This looks like a pretty good gear. Only now I want to change the diameter, the shaft diameter. So I'll change that to 10. Okay. Sorry for changing all those things, but these look like good settings. So a module of 1, 30 teeth, pressure angle 20, face width 6, hub style none, nominal shaft diameter 10, keyway none, and then you can show all 30 teeth. And when you're done with that, you can just say okay, and SolidWorks is going to confirm this part. I'll make a quick note right here. What happens is, if you look over here, you'll see that SolidWorks has made a bunch of, or used rather, a bunch of features to generate this part for us. And you may be tempted to go in and try to tweak this if you want to go back and tweak it, and you can, but be aware that it is very advanced over here. There's lots of equations going on. In fact, if you start clicking, you'll start to see weird Greek letters and whatnot, summations and other things going on with equations. So me personally, I'm not the brightest person, not the sharpest tool in the shed. So if I make a mistake with this, I'll just go back from scratch, and I'll come over here and I'll just remake the part from over here. Because for me anyways, personally, that's way easier than trying to mess with what's over here. You can though, I'm not saying you shouldn't, but just be aware that it's very hard to work over here. Okay, so now that I have this part, I'm not sure why, but it's just the way SolidWorks does it. If you go to save as, what you'll see is that SolidWorks gives it a very strange name, and it also stores it in a path that you usually don't use. So for me, I'm going to change it to my desktop because that's an easy place to find. And I'm going to name this, the way I would personally name it would just be 30, but we'll say Planet 30. The reason we're calling it Planet, with a planetary gear train, there's like a analogy between the gears and planets, suns, and then like a ring around it. So I'll just call it Planet underscore 30. Sure, we'll do underscore 30. And I'm saving it to my desktop. So that's my first part. So now that I have that, I'm going to close that, and I'm just going to make 2 more, well, three more parts, 2 more gears though. So I'm going to go back to my toolbox. I'm going to right click the spur gear again, create part. And for this next one, can someone tell me a number greater than 30? I guess it could be smaller than 30, but something other than 30. 50. Let's do 50. Thank you. And that should be all your other settings should be the same. So we'll say okay. And you can do Control S to save the part. And you can say, I would suggest save it wherever you saved your last part. And this one will be called sun_50. That's my naming scheme. You can name it 50. You can name it something different if you'd like, as long as you know what the part is. Okay, so that was quick and easy. We have one more gear to make. So go back to the toolbox. This time we want to do an internal spur gear. And we're going to call this a ring gear. And so the module we want to be the same so that all the teeth mesh properly. The number of teeth is going to be 110. And it's very important. It has to be 110 for this to work, right? It has to be at least close, and ideally it's 110. So that it matches up, we'll do the face width is 6. And for the outer diameter, I would suggest maybe 30. Something probably bigger than 25, which was the default, but I don't know if that's going to make a difference. Okay, we're not going to worry about it. You can just leave that alone. So we'll say, okay, so I think I made all this right. So hopefully I did. So I said, okay, and I'll save it.
What's the outside
You can do 25.
Okay, just wondering.
Yeah, I changed my mind on that because it didn't seem to be doing what I was expecting it to do. So I'm going to name it ring_110. Phil, you're just watching. Am I going too fast?
Well, there's no way, even if you're going like 1/10 as fast, there's no way. So I'm just gonna watch this.
Okay, sorry about that. I can try to help after. Lauren, you're doing okay? though?
Yeah.
Okay. How are the people on Zoom doing? Are you guys doing okay? All right, so I made that part, I saved it, so I'll close it with Control W. One more part to make, and we're going to make this part from scratch, actually, not using the toolbar, or the toolbox. And this is a part that we're probably going to end up changing some, but we'll start off with a very simple part, and it's going to stay simple, but we'll make it a little bit more complicated than we're currently going to make it probably. We'll see. So you can just draw a slot like that, and we're going to draw one circle right there, another circle right here. And this part is definitely subject to change, but let me see. So we're going to start off with the assumption that we want this distance right here to be 40. Again, this is subject to change. And I forget what my diameters were, but I think one of them, I think the inside one was 10. So for this, looks like we're doing a diameter. We'll do 15. Yeah, this could not be right, but it's not. The diameters are less important than this distance unit right there. I'll just set B2 to be equal. And this was a radius instead of a diameter, so let's cut that down to 7.5. Okay, that's okay. Once I get that, I'm going to extrude this. And we'll do it 6 millimeters, just so it's the same width as the gears that we made. Not critical, but just to make things look kind of right. Once I made or do that, then I'm going to save this. And this time we're going to save it also on our desktop. And we're just going to call it ARM.
Would you make the radius of the circles?
Which circles?
Like the two, like the whole.
The 2 holes. That diameter was 10.
Like the diameter?
Yeah, so the radius is 5. For the outside slot edge, I did a radius of 7.5 or a diameter of 15. I'm going to leave this part open. I'll close it. It's fine. I'm going to finally now make an assembly. And we're going to start using our parts that we just created through various means. 6 millimeters, which was the same as the gears that we made. So my arm came in first. So I am going to, the larger gear should be the sun. I'm going to fix the sun. My arm came in first, so I'm going to float that. And I'm going to start doing mates. I'm going to do a coincident mate between my two gears. I'm going to do a concentric mate. Actually, what I'm going to do is a coincident mate between those two edges. Those should be the same diameters, but my memory was correct. It looks like it was, so that's nice. I'll do a coincident mate between those two edges there. Oh dear. No, we don't want to open. Why would that be the case? Let's try that again. I drag that in a better position. Okay, now something wasn't in a good position. Okay, now I'm going to struggle to select that surface. And I want that to be concentric with the inside of my planet right there. Or I can also do like the inside of the arm right there. Both should have the same effect. And then we'll do a coincident mate between those two surfaces right there. And now this is a pretty simple planetary gear train with just a single planet, which isn't common, but it's like a really simple assembly. And we can make that more complicated if we want by adding more planets. But first, so this is fairly well constrained. The issue is that when I move my gear or my arm, the gears don't move how they should in real life, right? There's multiple solutions for this, but the best solution for this is to use what is called gear mates, which is a mechanical mate. So the first thing I'm going to do, actually the first thing I'm going to do is fix this arm right here. And that just makes it easier so that I can spin this guy so that the teeth aren't meshing like that, or aren't grinding, we'll say. And that's just to make it look right. It's not strictly required, but it makes it better, in my opinion. So once I did that, then I'll go to mates. And the gear mate is a mechanical mate because gears are mechanical systems or mechanical elements or parts. We have gear mate right here. And I'll pick the sun gear right here. It's important that I pick some curved surface, about a surface that has a center around which I want it to spin. So that means that for over here, I could just like pick like this curved surface because the center of that little arced surface is the center axis that I want this guy to spin about relative to this part. And since I picked this part over here, what I do over here is there are distances, but all I care about is that the ratio is the same as the ratio between them, the number of teeth. So that means I could just use the number of teeth for each part. So since I picked the sun first, that's this first box, that would be 50. And for the planet then, we have 30 teeth for the planet. So we'll do that and I'll say okay. And I'm going to X out the mate command. And when I did that, if I float my arm now, if I move this, we can see now that that goes around our sun as it would in real life. The thing I don't have yet is my ring gear working properly. So I'm going to move that so that like the teeth are no longer grinding, not interfering with each other. And then we're going to do another gear mate, and then this will actually be complete at that point. So go to mechanical mate. We'll do a gear mate right here between this planet gear and this ring gear right here. Got that edge. This curved surface right there. Okay, so the number of teeth in the planet is 30. For the ring gear, it's 110. And there's a good chance I'll have to come back and reverse this, but we'll not worry about that for the time being. There's a chance it's also right. So let's see here. Oh, I messed something up because that's not right. Okay, let's try that again. So I'll go back to my mates. I'll edit this. 30. Huh, that should be right. Right? Maybe I'll try reversing it. That might fix it, but I would have thought that that was right. Oh, there we go. I was wrong. Okay, I didn't need to reverse it. So now actually this, it's hard to tell, but this is basically how this would work in real life. And fun fact, I can talk quite a bit about planetary gear trains, but you have these four main components. You'll have a sun gear, a planet gear, a ring gear, and some arm connecting the planet to the sun. You can have multiple suns orbiting or multiple planets orbiting your sun. And you can have, right now I have my sun gear fixed. You can have the planet fixed. You can have the ring. That's not common, by the way. You usually don't have the planet fixed. You can have the ring fixed, or you can have the arm fixed. My personal favorite, because I think it's the coolest, is to have the arm fixed. Because when you have the arm fixed and everything else free, you spin something, all the gears spin, and I think this is kind of the coolest. What I'll do is I'll go to my motion study, and I'll add in SolidWorks motion. We'll do a motion analysis with a relatively high frame rate. And we'll add a rotary motor to our sun. And I'll say okay. And then I'll go ahead and I'll calculate that. So here's just a basic motion study of our system. So I'd be very impressed if anyone kept up with that. Sorry, I get excited with planetary gear trains.
That's fun. I mean, it's fun stuff for sure.
Yeah. So does anyone have any questions? Is anyone stuck and would
What
like
were
help?
the mates that you did?
So let me stop this and go back to my model.
I kind of lost track there.
Yeah. So
The two, the sector ones to the like, what part is it?
to the arm.
Yeah,
Okay.
that's it.
The concentric mates, do you do coincident mates between like that surface and the inside surface of the arm? By the way, you can either hide or make parts transparent. So I'm going to change the transparency
I
here.
didn't get that.
So yeah, do a coincident mate between the surface right here and the surface of your sun gear, and same thing with the planet and the arm right there. If you click the part, there's an option called change transparency. You can toggle that on and off. It's a binary state. You can have it be transparent or not transparent, opaque or. How are people on Zoom? Peter, how are you doing?
Yeah, I'm good. I'm good.
Okay.
Just following, listening.
Do you have any questions? For anything that I did?
Yeah. I'm good.
What was that? Sorry, my.
Yeah, none for now.
None for now. Okay, let me know if you do have any questions.
Okay, sure.
Thanks.
Like, we did the coincident to both of the years.
Yeah.
Okay.
Oh, I guess I could have made it a little bit easier on you. You could also do like, this would do the same function, but you could do a coincident mate between like those two surfaces, right? So let me know whenever you get that. Phil, do you want to follow along or no? It's
Which
fine.
one?
Well, for any of this.
I'm just watching.
Okay. Do you have any questions for what I did?
No, I'm fine. I mean, I understand what you're doing, but it's just too quick for me to do it. I mean, way too quick. I haven't worked with gears much.
Okay. I think gears are awesome. Especially like worm gears and whatnot. Okay.
What's the next?
So you can do a concentric inside of your sun.
That's
It's not good. Why is my internet connection not stable? It's the present state. We're supposed to have good internet. And there's not even anybody here hardly. Shouldn't be a high load on the internet. Oh, it's probably because everything's updating. So sorry if I sound like a robot online to you guys on Zoom. Not much I can do about that though. You got that?
Yeah.
Go ahead and do a coincident mate between the side of the teeth on your
I
ring
think I
and
have,
that.
yeah,
You got that?
yeah.
Okay, so then all of your standard mates should be complete then. Does it look kind of like this?
Yeah.
Okay, so then it'd be the gear mates that you're missing, and there's only two that you need.
Okay.
So if you go to mates, mechanical mates, it's a gear mate that you want to do.
Okay. You did like the middle.
Yeah,
Circle.
yeah, that's probably the easiest. Of course, there's more ways you can do it, but you can just do the centers. Like the center right here.
The
to the
centers of the
center.
two gears.
Yeah, centers of the two gears.
Okay. And that, the ratio thing.
The ratio
It's
thing.
the-
So whichever gear you selected first, in the first box right there, enter the number of teeth that gear has. So if you pick the larger one, the sun gear, that's 50. If you pick the planet gear, it's 30. And then whichever one you pick second, enter the number of teeth that gear has in the second box. So it's either going to be 50 to 30 or 30 to 50. You could also do 5 to 3 or 3 to 5. You can reduce that. So it's a ratio, but usually I don't think that much about it. I just do the number of teeth because that's always going to work out. Should always work out.
Let me see that. They're not going in the gaps. I think I forgot.
Oh, that's
Yeah.
fine. Yeah. Oh, one other thing too, it looks like fix your arm so that everything's not floating around. I think they'll have a better time with that now. Yeah, that looks good. So then the next step for you is to do a mate between your planet and the ring gear. Similar procedure. The only thing is if it doesn't look right at first, go back and edit your gear mate for between those two parts that you just mated and check the reverse box, and that will hopefully fix any issues you run into. The difference there, I don't even remember fully the equations that are going on here mathematically for like the analysis side of this. But basically, when you have gears that are meshing two external gears, like the sun and the planet gear, you have a change in signs in the direction. So like one's going to spin clockwise, other one counterclockwise. But then when you have a mesh between an external gear and an internal gear, like the ring gear's internal gear, the teeth are on the inside, the gears are going to spin the same way. So that's why you have that reverse option for your gears. A lot of information, I know. How are people on Zoom doing? Did anyone get this assembly? It's okay if you didn't. Oh, you got the assembly, Peter? Okay, I'll take your word for it. Let me know if you want any help with anything.
All right, take the arm off the float.
You can if you want. You can, if you do that, I would say fix one of the other parts to make it kind of interesting. You could fix the planet on the ring.
Oh, there we go.
It'll do what?
Yeah, it's just because it wasn't moving around.
Oh, I
because
see.
of that.
I see. I see.
So I thought something was wrong for a second.
So I guess while people are finishing up, what I'm going to do, I'm going to make this a little bit more complicated, but I don't advise that you do this unless you really want to. I'm going to open, by the way, I can just click on a part in an assembly and open it up as an individual part. That's what I just did right now. And what I'm going to do is I'm going to come in here and edit my sketch. And I'm going to do, we showed you linear patterns, sketch patterns, but we talked about, but we didn't really use circular patterns. So I'll take this opportunity to teach you about these. So I can, oh, not that. Let's take that. So I want to rotate that around. Oh, sure, let's do the whole slot. And we'll do it 5 times. And I'll say okay. And the issue now, actually, I'm not going to mess with trimming, but we will say show problem. Okay, I do that. So, okay, I'll just exit the sketch and say exit anyways. And when I do that, my extrude breaks, but I should be able to come in here and select multiple areas, which is the other option is to trim the lines. The problem that you'll run into if you do that though is the slot feature doesn't like to be trimmed because it destroys the slot, and you have a bazillion error messages if you do that you have to close out of one way or another. So I think this is slightly faster, but maybe not. But there we go. Oh, I forgot to pattern. Another thing I wanted to do. Oh, it's okay. I forgot to pattern the circle. So that's quick enough to do. So, 5 times. And I may get an error again. I didn't, but I kind of did because it. Shoot. Why did that happen? Why does it look like that? That's not right. Okay, the other option I have is I can just come here and I can do it as a cut. And I could exclude that, but I don't really need to. I'm going to now go and say extrude cut, and we'll just say up to next. What? The thing I'm doing is working. Okay, let's try a third method. Now that I have that cut, I should be able to do a circular pattern. So direction would be that curve surface. And then features. It's not working. Oh, it's trying to say the normal direction there. That's not right. I want to go around that circle. I don't know why that wouldn't work. I would think that that would work. So I guess one thing I could do, I'm spending more time than I wanted to on this. So let me just come back in here. And I think it'll be a little bit easier in here. Oh, I think I forgot to say okay with that. There we go. Okay, sorry about that. This goes back to I'm not the brightest bulb, but that's okay. Now I have that, I'll save that. And what that allows me to do, now that I changed that, it should automatically update in here, and SolidWorks is giving me errors, but that's okay. I can just delete those mates that were causing issues and I can recreate them. We already have that. I think we still have that mate. I think that what I'm missing is this mate. And maybe that mate. Well, let's see what's broken. Oh, that's what's broken. I need to that edge. That. Why is he not? Let me suppress that. I usually suggest that you suppress mates instead of just deleting them in case you decide you want to go back and change it. I don't know why I wouldn't be able to make that mate. So I guess I could try like this. Okay, let's see if that works. Okay, that works. Now that I have that, I can also probably, hopefully do a circular pattern in here with that planet around this direction, maybe? Okay, there we go. We want there to be 5 equally spaced. And once I do that, it's all fixed. Oh, I think I'll have to come in here and maybe make this flexible. That would be the way to do it. I don't know why that's not working. Oh, now it's working. Okay, I don't know why it wasn't working before, but so anyways, this is just to show you, this is functionally the same. All the math actually turns out to be the same. The only difference is in real life, this part would last longer because there is more surface area to dissipate the stresses that these gears would bear. Anyways, sorry about that. So I'll just save that. Sorry for the delay. Does anyone have any suggestions for a different topic? You guys want to do another assembly problem? And it'd be basically a mate problem from here on out. We have angle limit mates, distance limit mates. We have a cam mate. Cams are fun. We have symmetrical and width mates. I'm a big fan of width mates. I use those a lot. We also can do more drawing problems if you guys would like. More assemblies.
Show us the cam.
The cam?
Yeah,
Okay.
that's a fun one. You showed me that one last year.
Okay. We'll try it. Before, I haven't had the best luck with cams. However, with SolidWorks 2020, I've actually had really good luck with cams. So hopefully we don't run into any issues. So you can navigate to the assemblies mechanical cam mate folder and open up all those parts in a fresh assembly file. Oh, whoops, I opened them as individual parts. That's not what I meant to do. Don't do what I just did. You want to create a new assembly. And then you want to open up all the parts in that assembly. Cams are really fun. I think, and I'm probably in the minority in this opinion, but I think it's actually fun to do the math behind cams. We're definitely not doing that right now though. But if you're in the mechanical engineering department, you'll get to at some point. So let's see here. So when you get all your parts in, I would suggest fixing the shaft and floating all the other parts. So like the follower and the cam itself. Is anyone familiar with how cams work besides you, Phil? Lauren, do you know how cams kind of work? Okay, they're simple. Basically, the gist of it is you have some part that revolves, and that revolving part usually is not a perfect circle. It usually is like a pear, kind of like this one, or some other shape, and it's going to have some follower like this that is touching it, and then when this revolves around, the little lump in it will push up the follower. So you can use it to like open up valves
In your car.
yeah, car is a very common place for this. In fact, like in your crankshaft, I'm pretty sure that with your pistons that you use kind of like a cam system to drive your crankshaft that then in turn will eventually turn your wheels in your car. I think that's at least somewhat accurate. It may not be. If there's someone here that knows more about cars than I do, feel free to speak up. Okay, so I would say fix the shaft and have all your other parts free to move. And I'll go ahead, I'll teach you guys about a different mate while we're here. I'll teach you about the width mate. You use that when you want to not do math, is usually when you do it. It's an advanced mate. And what you have are usually four surfaces that you select. So for my width selection, I'm going to select this surface and this surface. And then for my tab selection, I'll pick this surface and this surface. And what that mate does is it centers these two surfaces between the outer two surfaces. And the order of those two surfaces actually doesn't matter. And I show you what that looks like using the mate selection up here. But usually the way I try to do it is I'll select the surfaces just by holding the control key and selecting all four of them. And usually a little menu will pop up and give me the option to do a width mate. So I'll try it with these surfaces right here. I'm going to try another width mate right here. There's the width, so that's what it is right there. Width mate. So does that make sense how the width mate works?
Just use width mates for a while.
Yeah, I like them. They're very handy, and you can do a distance mate instead, or in this case right here, you can also do like a coincident mate between those two surfaces because it just so happens that the width of our cam piece is the same as the width of the head of our follower piece. That's a coincidence. If that's not the case, you probably want to say that one way or another. And the convenient way, the math, I won't say math free because the computer's doing math for you, but the way on you to not do math is to use a width mate. So once you get this lined up kind of like this, we have two more, I believe it's just two more mates to go. We want to make sure that this cam stays on top of, sorry, that this follower stays on top of our cam system. And to do that, we're going to do a coincident mate between a plane and this follower and a plane in our shaft. And hopefully actually, so what that means is first what I'm going to do is float my, no, that doesn't matter. I take it back. I'm not going to do that. So I'm going to start the mate command. And what I'm going to do, this is something that I haven't done yet, but you can do mates between planes and surfaces, surfaces and surfaces, or a combination thereof. But what I'm going to do is I'm going to go to my shaft. I'm going to look for a good plane. And it looks like the right plane in my instance is a good plane. I'm going to pick that surface. And then in my follower, I'm going to look for another good plane. And it looks like the front plane is a good plane. And then we're going to do a coincident mate just like that. And now when I do that, this piece is now free to go move up and down. That's what I want. I want a degree of freedom for my follower to go up and down and for that to be actuated by my cam. That's the goal here. The last mate that we're going to do is called a cam mate. That is a mechanical mate. See it right here. So the cam path is this smooth surface right here. It used to be the case that the path had to be a single curved surface, or just a single surface, I'll say. I don't think that's no, I don't think that's still the case. It may be, but either way, we have a single smooth surface right here, so we're good to go. And then for the cam follower, you can just pick that point right there on that edge. And then that should be everything that you need to finish your cam assembly. Once you have that, you should be free to spin your cam around and it's going to move our valve up and down. And what you saw, if you were watching my screen, what you saw right there is the follower collapsed into my cam, which is what you don't want, but what sometimes happens. That used to happen a lot before SolidWorks 2020. I'm just going to make a quick motion analysis of this because it's very easy to do, or very quick to do also. Maybe not very easy, but it's easy enough, I think, and it's fast usually to do. Phil, are you following along with this one or no? Okay.
Actually, I could do this. I mean, this is pretty straightforward.
Yeah, it's pretty straightforward. But you can do a lot with the cam system. Sorry, what was that?
You did coincident mates with planes?
Oh yeah, that was a bit more involved. I'll go back to that as soon as my calculation.
I'm trying to do that, but it's with no plane inside of it.
Oh, if that's the case, you have a few options. Let me look at your screen and see what you're looking at.
I'm trying to make one between this, right?
Yeah, between the shaft.
Mm.
No, not those planes. Those planes are, oh, actually, unless you're trying to just line it up. Are you just trying to line it up?
I think so.
So remember that you probably fixed your shaft. That means your shaft can't move. So if you're trying to And then these planes that you're hovering over, that's the coordinate system in your whole file. So that's by default fixed. So if you're trying to make two fixed items, they're not going to move. So you may get an error if you're trying to do that. So you don't have to. What you could do, which is what I did, is you can go back, start the mate command, and go to drop down your shaft part over here. Oh, sorry, follower. You can do that.
Yeah.
So drop it down with a little black triangle. And then hover over your plane. So probably the front plane looks good. So you can select that and then drop down your shaft over here. Black triangle is fine left of the shaft. And hover over these planes and see if good. That looks good. That looks good. So yeah, you do the right thing there. And that's it's trying to do a tangent mate. And for some reason, we don't have the option to do a coincident mate. That means that something's constraining. So since that's the case, it's not going to. Oh, unless it lets you do it. What happens if you stop? Can you show me what mates you currently have?
Oh, yeah, I think correct delete a couple of these.
Well, that's
They're fine.
yeah, those. Actually, kind of look at those. These mates are doing what I think they're doing. So what should I'm going to try to do it. So, you went to mechanical camming, right? Oh wait, no, sorry. So, we can select it now later. Oh, the other option. Let me make sure. This is correct. For some reason for me it's working. Go ahead and try it. Try it again. Because I watched you and looked like you did it. Okay. Yeah, sometimes being
I did not see that one. I was stuck trying to.
yeah. So if you go, let me go to my model. If you start the mate command again and you go to mechanical mates, cam mate is actually the first option for the mechanical mates.
Yeah.
So when you click that, it's very simple. The cam path is just this curved surface. And then the cam follower is your second option. Just pick like the midpoint right there. You can also pick like a vertex too if you want on that along that edge. And then you can say, okay, make that, and you should be able to move that around. And then if you want, you can make a motion analysis or a motion study if you want. Not necessarily required there for this workshop. How are people on Zoom doing? Good, cool. You don't have any questions then? Okay.
Nah, no questions. Yeah. It's
Awesome.
going great.
Awesome. Okay, so I think we have time for another example. So I think cams are fun. So I'm glad that we did that one. I'm also glad that we did that planetary gear train. So we could do, there's a lot, I think, in this symmetrical and width mate. We can do, I think, let's see what this looks like. Sewing needle. Don't know if I've done. Oh yeah, this is good. Oh, sorry, swing needle picture. So this is the metronome, right? This is a good problem. I like this problem.
Metronome?
Right?
Oh,
I
yeah,
think.
looks like.
Yeah, I think that's what it is. I actually am not musical whatsoever. I think that's what that's called in music. Used to keep
It's like
time or
an
keep a
old
tempo.
time.
Old time? Okay, well.
Now
they
they're
ha-
just on the phone.
yeah, my family still uses them. Not my immediate family, but my family still uses them. But my
Yeah.
family could be pretty old. Anyways,
I have them too.
okay. So let's go for that one. So that's angle limit. So make a new assembly, begin a new assembly, and then select those parts. And you want part 1 to be fixed. You want part 2 to be floated so you can move it around. And this is a good problem. We can probably get this done, no problem. So somehow you want to get your needle onto your metronome body. So does anyone have any suggestions for that? Phil, you can do this problem. Good.
You're saying suggestions?
Yeah.
Just concentric, right?
You can do concentric. And then what would you do from there? So I'll do that.
Concentric. And then probably line up the coincident as far as the plane, the back plane of that, front plane of that, yeah. Those two are coincident.
Okay, that's one option to get the needle on there. Check this out. Usually it's easier on you and easier on SolidWorks if you do as few mates as you can to define what you want. So if you wanted it to be defined like that, what you could do is you could select this edge right here. Because that is the same diameter as this edge in here, you could do a single coincident mate right there, and then you should get the same effect. So your way works and your way is good, but this is just one less mate to do it. Another way that you could do that, just another option that you have, is you could line up like the needle right on the edge. So it might fall off if it was in real life. The option that I like doing personally, I like to use 2 mates. I like to use to line this up concentrically. And then I like the width mates. I already told you guys this. So I like to select these surfaces here to basically center the needle. And I guess my rationale for that is I don't want the needle to fall off, but at the same time, I don't want it to be rubbing up against there. So I like to center mine, but somehow, moral of the story, get your needle on here so it's free to swing back and forth. And then let me know when you guys get there. Phil, you can follow along if you want. This is a pretty quick, easy one to do.
That's more fun to just watch. This is pretty simple.
Okay, true enough, fair enough.
I'm redoing mine 'cause I like the work one.
I've corrupted one person already, Phil. Just because I like something doesn't mean you guys have to like the same thing.
Are you gonna constrain it between the 2 pegs? Is that how you're gonna do it?
Yes, that's the idea. People on Zoom are doing well, hopefully. Okay. So because I haven't introduced the mate yet, I'll introduce the limit angle mate. It's an advanced mate, and I think it's kind of worthy of the name advanced mate. It's not terribly advanced, but I think it's worthy of the title. So how it works is you usually select 2 planar surfaces that are free to move with respect to each other, and you define 2 angles. Usually you could define actually 3 angles, but usually it's 2 angles that those planes or surfaces are free to move and make with each other. So we're going to use that to confine this needle in between those 2 knobs, basically. And I don't remember the angle off the top of my head. It's actually an easy angle I remember. I think it might be like 15 or something both ways, to like 30 total from here to here. I think that's what it is. And we can find that out by trial and error. But in my opinion, the better way of doing that, we can go normal right here to the surface, and we can just draw a line. This is the way I would suggest doing it. To the center right there, and then another line to the center or rather actually to this edge. And then what I want to do is actually, oh, you know what? I'm not quite sure if we can do this, but we're going to try to do it. And if we can't do it, I know a solution to make it work. I'm going to select that line in this. Oh, we can, and make that tangent like that. And I'm going to do the same thing over here. That surface. That circular right there. Okay. And once I have that, now I can measure this angle in here. My guess is that angle is going to be 30. Oh, it's not 30. That's interesting. Now I have to think. So I think that that means that. Oh, okay. So my simple thought is not quite accurate. You need to. I'm pretty sure that you need to account for the width of this needle head. So for the sake of time, this is probably more involved than I thought. We can come back to it tomorrow if you'd like, but we can still finish actually this example. So basically the angle from here to here is 30. When you account for the thickness of the needle, I'm going to exit my sketch. And what I'm now going to do is go to mate, and it's an advanced mate. You want somewhere here. The last one it looks like is called limit angle. The first angle there, you don't need to worry about. That's asking you for like what the default angle is where it's starting off. We don't really care about that. Actually, first I'm getting ahead of myself. First, we want to select in part one, whatever plane cuts this in half, or would cut it in half. So we'll pick the right plane. And then in part two, looks like we want to also pick the right plane. Okay. So the maximum angle we want to make, let's try to flip the direction. I think we want to say 15 in here, half of 30. That looks right. You can see that lines up properly. And that would mean the minimum distance we want to do, I think would be -15, but SolidWorks doesn't like negative numbers. So let's try 245. Yes, 245 would work there. So that's the minimum angle. Let's, I didn't change that one. I don't want to change that one. Okay, I'm just going to make this. And I'm trying to edit it. It's not going to work. Yeah, it's not going to work how I want it to. Let me try to edit this. So I know that the two angles I want to go between. Oh, that's a standard mate. I don't want a standard mate. I want an advanced mate. Here we go. Oh, I see. I see. Because, sorry, this is my error. I think, I hope. Since 345 is a larger number than the other, than 15. Let's try that. 15 is the minimum. Let's see if that'll work now. Okay, so now actually it's choppy. Oh, and I guess I have it backwards. I guess that just means that we can. It's not working. Okay, now it's working. This is a buggy mate, and usually it's not this buggy, or it hasn't been in the past for me, but we can see that this is now free to like go in between, and sometimes it breaks. I'm pretty sure that's it breaking. And if we have a concern about that or a doubt about that, we can try to use a motion study to see if that is the case. So I'm going to use a rotary motor. And instead of a constant speed, I'm going to oscillate 30 degrees. Currently the opposite direction of what it's showing because we're starting off over here. 1 hertz, 5. I think my default time is 5 seconds. Let's see what happens. I'm just going to calculate this and see. Okay, so that looks right. Wow. Okay, this is a proof of concept. I guess this isn't really proving that the mate's working. It's showing that the mate is not constraining that though. So, okay. Hopefully there's not too many questions for this. Sorry if that's confusing now. But the moral of the story is that based on the computers in 385, which is a civil lab, the limit distance mates are pretty buggy, but hopefully this kind of makes sense. Is this completely confusing or does it make a little bit of sense? We can come back with a much simpler example. I have an example that I've shown before where it's just like a hinge. In fact, actually a hinge would be a good example to do. And also I've done it like where it's like a thin piece of paper and it's kind of like a small book. It's actually like a menu I can open and close. But this is in a nutshell how the limit distance or limit angle rather mate would work. You select a minimum. Well, first you select two planes, the two surfaces, and then you select a minimum angle that those planes can make or surfaces can make and a maximum angle. And then it should be free to move in between those two positions. That is the idea. So I'm going to save this and we are officially out of time, but I will stay back if anyone has any questions. If not, then everyone is free to leave whenever you would like. So are there any questions?
Thanks again, Noah. It was a wonderful session.
You're welcome, Peter. I think I'm going to stop sharing and stop recording.